Hello everyone, today I will show you how to perform maximization using Excel, Microsoft Excel, and this is one of the examples available in optimizations of hydropower problems. This is exercise 1 for maximization example. The exercise is a farmer owns a total area of farmland is 100 hectare, and he plans to plant at most 3 crops, and the seeds for 3 crops ABC costs 40 TONI and 30 per hectare dollar respectively. The farmer has a maximum of $3,200 to spend on seed. So crops ABC requires 1, 2 and 1 working days per hectare. That means for crop A it requires 1 day per hectare. For crop B it needs 2 days per hectare, and for crop C it needs 1 day per hectare working day, and there are a maximum of 160 working days available for this farmer. And if the farmer can make a profit of $100 per hectare on crop A and 300 per hectare of crop B, and if $200 per hectare on crop C, how many hectares of each crop should be planted to maximize the profit? Therefore, the farmer needs to maximize his profit. So the first constraint is working day. It's a limitation. There are 160 working days. Is one constraint. The other constraint is a maximum of cash available for buying those seeds is $3,200. This is the second constraint. This is the first, this is the second, and the other constraint is the farmer has 100 hectare of land. Here different color coding shows the 3 constraints here: land constraint, here seed price constraint, as well as working day constraint. So using these constraints, a farmer plans to maximize his profit. So how can he maximize his profit? Using if crop A costs $100 per hectare, and if crop B earns a profit of 300 per hectare and 200 per hectare for crop C. So this is the overall concept for this exercise. So in order to solve this example exercise, so here the first thing is to obtain objective function, and the second step is to obtain those constraint equations, and the third one is to obtain non-negativity constraint. This is not, of course, not a matter, because this crop A, crop B total area is cannot be negative, so it's very simple. And the final one is open solver in Excel, and finally solve it. So when we come to this let's symbolize x1 is the numbers of hectares for crop A, and x2 is for the numbers of hectares of crops for B. So the farmer intends to allocate for crop 1, crop 2, crop C the area for land. So therefore x3 for the numbers of hectares of crop C, and P symbolized for total profit. So the first thing is to obtain the objective function. So our objective function is P per profit needs to be maximized. So P is equals to 100 costs for crop 1, that means 100 times x1, 100 times x1 here, land for crop 1. This is because of per hectare. X1 times 100, x2 times 300, and x3 times 200 can be the objective function. So the objective function is 100 times x1 plus 300 times x2 times 300. This is the objective function. The objective function actually. So the constraint is here land constraint, the total hectares of land cannot be greater than 100 hectares. This is land constraint. This is land constraint. The other one is seed price constraint. The farmer owns $3,200 for buying the seed for each crop, crop A, crop B, and crop C. Therefore, for crop A, this is $40, and for crop B, 20, for crop C, 30. Therefore, this is per hectare actually. Therefore, per hectare, this per hectare is necessary. If times the hectare, it will cancel hectare here. So here per hectare as well here. This is days per hectare. This is per hectare, yeah. So 40 for crop A, 20 for crop B, and 30 for crop C. Therefore, needs to be, this is the summation, the cumulative price needs to be less than $3,200. This is actually cost constraint. Yeah, the other one is working day constraint. So there are three constraints available here: land constraint, as well as cost constraint, as well as here working constraint. So working constraint, 1 times x1 plus 2 times x2 plus 1 times x3 must be less than or equals to 160 available working days. As you can see, these are the coefficients, so needs to be less than 160. So this is constraints, but here also non-negativity constraints. Those area of land for crop A, area of land for crop B, and area of land for crop C needs to be greater than or equals to 0. Needs to be greater than or equals to 0, but cannot be negative value. So this is a negativity constraint term. Therefore, finally, we have identified these negativity constraints. So the final one is to use to open solver in Excel. So open Excel here. These are the constraints, the negativity constraints. On individual cell here, insert the value for x1 greater than or equals to 0, 0 here. For this one, in a single cell, put the value x1 plus x2 plus x3 needs to be less than or equals to 100. In a single cell, put the value as well as this equation. So this equation is not mandatory, but you need to insert in a cell these values, which is a must, as well as here p value in a cell here. You need to put in such a way. So finally you need to write this equation here. P is equals to, then open bracket, then here as you can see 100 times x1, 100 times x1. Where is x1? x1 is here. X1 is a space here, x2 a space here, and x3 is here. So x1 this one. Now close brackets, then plus, here open 300 times x2, 300 times x2. x2 is here. This is the value of x2. So close the bracket, then plus, open bracket. So 200 for x3, 200 is the coefficient times x3. x3 is not this one here. This is actually this is the value in which solver puts the values. So x3 is this one. Now close the bracket and now hit enter. So P is a profit here, total profit. Now open solver. This is Excel 2007 version for others solver add-ins will be available in tools menu. For me this is 2007 and click here data. This is solver. If it is not available, make sure you have to check here, right click on the space here, right click, customize the quick access toolbar, then here available menus here, click on add-ins. So here choose Excel add-ins. Now go. Now if it is not available here, make sure check this one. For me, if it is this one, it will be inactive here, but you can add in your Excel here your Excel add-ins. Go, make sure or check this solver add-ins, then press finally OK. It will available here. Now you can get from the data or from tool menu, which is not available in 2007 version of Excel, Microsoft Excel. So click on data, then open solver here, reset all. I have to reset all. Now set objective. Our objective is cell p-value, this one. We need to set this objective to maximize. So click this one. If it is minimum, click this one. If it is maximum, click this one. So our target is to maximize this p-value or k5. So by changing variable cells, this x1, x2, x3 are variables. So I need to select these variables. So click this one. Subject to the constraints, there are around 6 constraints, therefore I have to insert these constraints in such a way. Click by adding here, add here. Cell reference are these values. These values are cell references. These are constraints, constraint equations. So cell reference, for example, for this one, cell reference is this one. This one, if it is equals to less than or equals to, so here convert to greater than or equals to, change, because it's already shifted. This one will be this one, and this one will be this one, and this sign will be replaced with the other one. So constraint is x1 plus x2, x1 plus x2 plus x3. So here are the first constraint inserted in such a way. Now the second is constraint. Click this one, convert this one. So constraint 40 times x1 here, open bracket, 40 times x1, 40 times x1, close, then press here plus, open bracket, 20 times x2, open, then plus, open bracket. Now 30 times x3, x3 is this one. Now close, then click here, add. Now we have inserted this second constraint. Now the third one, this one, convert this one into this one. So constraint x1 plus bracket 2 times x2 plus x3. So add, click here. Now we have inserted these 3 constraints. Now the negative constraint must be inserted here. Constraint 0 here. This is greater than or equals to, so here greater than or equals to will leave as this. So constraint x1, so add here. This is the second one here. Now I will leave as this constraint x2. Here click add. The other one is the third one and the final one as it is. Okay, now x3. Then finally, after finished by filling those constraints, we have around 6 constraints, including non-negative constraints. Then finally press OK here. As you can see, these are the 6 constraints available here. Select a solving method: simplex, linear programming method. You can use simplex. You can use JRG nonlinear. You can use evolution. So it's up to you. So you can use based on your interest. You can solve. So you can select a solving method. So finally, after you have finished those entities, then finally click on solve here. Solve here. Keep solver solution. Press OK here. So okay. Now as you can see, the maximum profit can be $26,000, and the area of land for crop 1 is crop A actually is 0. Crop A is not necessary and profitable. That's not profitable, so you can eliminate crop 1, crop A. So using crop B and crop C, you can maximize your profit, and crop B having 60 hectare of land, his land for crop B, and 40 hectare of land for crop C. He can earn a maximum profit of $26,000, and this is all about